And welcome back, folks. We're continuing our big O notation work. Previously, we did an analysis on a linear example. This time we're going to look at a more polynomial function. And the nice thing about this is that it's going to be pretty easy to analyze. So here I have the ax squared plus bx plus c. And we know that has to be equal to big O of x squared because x squared is the largest power there. So I can rewrite that as ax squared plus bx plus c is equal to x squared, parentheses, a plus b over x plus c over x squared, because I pulled the x squared out, which of course is the same as x squared times a plus absolute value of b over x plus the absolute value of c over x squared. When x is greater than or equal to 1, therefore my absolute value of b over x has to be less than or equal to b. Remember, this is only when x is greater than 1. If it's less than that, it's not going to work. The absolute value of c over x squared, it has to also be less than c. Thus, I can conclude that ax squared plus bx plus c is less than or equal to x squared times the absolute value of a plus the absolute value of b plus the absolute value of c. So pretty much you're just going to take and add the coefficients with the polynomial, which is really pretty easy compared to what we looked at with the linear function from yesterday. So let's actually look at this though with our big O of f of x equals 3x squared plus 2x plus 1. And similar before, we want to find c, n is greater than 0. Therefore, x is greater than or equal to n. So 3x squared plus 2x plus 1 is less than or equal to cx squared. Following our rule from our previous slide, 3x squared is less than or equal to 3x squared. It's equal, so it works. 2x is less than or equal to 2x squared. Now that's correct. And 1 is less than or equal to 1x squared. Yeah, that works. So therefore, we can use our rule, and because the absolute value of 3 plus the absolute value of 2 plus the absolute value of 1 equals 6, we can conclude that 3x squared plus 2x plus 1 is less than or equal to 6x squared. Our c, of course, is 6, and x squared equals 1. So let's conclude this. Just like we did last time, we're going to figure out what that is. Because remember, f of n is equal to big O of g of n. So we prove the function, so let's map that algorithm to big O notation. So in this case, f of x is equal to 3x squared plus 2x plus 1, which is equal to big O of 6n squared. Or if you want to put x squared, it's fine too. But that would be our function. That concludes everything, folks. We now have had 2 different examples. Until next time.